So I can, okay, I can look at this one.
Because we have this data. So please look at your screen and keep talking this down.
Good afternoon to everybody. Today is our second day of the Geospatial Web Services pre-conference workshop. And we'd like to start with a recap of yesterday. So yesterday, what we did was we tried to have a basic understanding of how you can be able to discover your data. So that was basically the gist of the day. And after having that, we also tried to explore the Geospatial Catalog service for the web. So those were that was the catalog that we're looking at, the Geo portal. And we also said that first of all, for us to be able to access the data, we need to make sure that this data is documented. So the documentation allows us to be able to discover the data and then also be able to evaluate and access the data. So that's what we said. So just having a basic review of yesterday. Yesterday we said, rather we studied about spatial data infrastructures and fair data. And we said that first of all, we say that this data is very important for our society and our business needs. And we have data from multiple institutions. That's what we said. We said that we can be able to utilize this data and combine it together and be able to make informed decisions. And I gave you a case of planning, whereby you need, if you want to make a sustainable plan, you need to make sure that you get data from multiple institutions and be able to maximize it to make a plan that is well informed. If you are going to spend money somewhere, then maybe you need information from multiple stakeholders so that you have a plan that's well informed. And we said that more than 2/3 of the sustainable development goals are visualized spatially and can be, of course, we can be able to combine this data and help in supporting decision-making as far as these goals are concerned. So we say that we basically have two kinds of data sets that are possible. We have the fundamental data sets, and then we have the thematic data sets. So we say that basically the fundamental data sets form a common information framework, usually from a trusted source and maintained. They are required by many sectors, and they add value to other data. So, and they're required for many applications. And they underpin other information, and they're also common between applications. And then I gave you an example of if you're told to create a map today, there's some data that will have to appear. For example, the administrative boundaries to give you the boundaries of your work, or the roads data set to give you the context. So that is basically fundamental data. And then we also say that there is thematic data that is categorized according to a theme. And we had here an example of a theme like natural environment. And then the sub-theme would be forestry, soil, or water. And then the data sets would be soil erosion, and then air quality or deforestation, imagery, or any other data sets. So we categorized it. So I had a slide that was showing you these data sets. And also, so I showed you the fundamental data sets. So the ones that I'm illustrating here, or that I'm showing, the data sets to do with, they are data sets from, they are data sets basically based on a classification that has been provided on the African continent. The initiatives that are possible, that are rather existing here. But it's also very possible to have different kinds of classifications. So maybe when we have a definite one, then maybe this could change. But for now, that's the classification that's there on the African continent. And then we say that we have basically thematic data sets. So an example of these thematic data sets includes, for example, the building, land use, human and health, safety, or something like that, and then utility services, for example, for the water sector, electricity. And we also say that we have, for example, from the meteorological sector, and then also the agricultural sector. So these are themes, these are categorization, for example, according to the sector, or maybe according to some kind of criteria. Now, we say that ideally, if you want to get data, you need to get it from, you need to get this data from what we call a metadata catalog. Other people call it a spatial data clearing house. And others call it basically, they call it just a geoportal. What you see is basically a website, and on this website, it's a one-stop gateway whereby the providers of the geodata basically archive it on the geoportal, and then we have the users coming to the geoportal and using the available metadata to be able to evaluate. First of all, they discover the data, they evaluate whether it's important for them, and then they can be able to utilize the data for their own purposes. So I'm just having a recap of yesterday. You'll allow me to be a little bit faster. And then we said that I gave you links for you to be able to search and be able to access the metadata. And then I told you that check the metadata and then tell us what you think about the data. So you can just go to any of these links, search, and then be sure that maybe there is metadata on the data that's provided or not. So I've given you data, rather catalogs for the country, also catalogs for the region, as well as the global domain. So these basically comprise of the network services that are in the SDI. Then we say that there are other initiatives where people just put the data on the websites. And we say that the disadvantage with this one is that you'll download the data, yes, it will be very available, yes, but you evaluating and finding out whether this data is really useful for you becomes complex. And then yesterday we said that, so to have an appreciation of metadata, we basically use this metaphor of food. If I told you to go to the market and buy food, and then you found one that was having some tags and one that doesn't have tags, which one do you think that you can use, rather you can buy? So how do you really evaluate correctly the food that you want to take home? So someone may tell you it's fish and you reach home and it's beef. So, or he may tell you that this is good and you reach home, it's expired. So we need to make sure that we have tags to be able to help us to evaluate our data sets and find out whether these data sets are useful for us. And we said, for example, for food, the tags would be the expiry date, manufacturing date, the ingredients, and so many others. For example, the manufacturer, you want to know that person, and rather that organization. And so also for data, we have things that we ask ourselves when we find data, rather find data somewhere archived on the portal or in a database. You want to know, for example, what data set it is, what it is about, and you want to know the purpose. Why was this data collected? You want to know the context. You want to know the context for the data. You also want to know how and when it was created. And you want to know in what format the data is available. You want to know where it originated from. And you want to know, for example, at what scale it was created, what are the attributes, what are their meanings. So these are the things that you want to know. So we say that metadata is very important, and if you don't have metadata, then it's not easy for you to be able to discover and later on compare data sets, and then also be able to evaluate the data sets and be able to use them. So we also talked about the fact that if you wanted to access it, you'd get maybe upon request, or maybe you go to the portal, and in that portal, you'll be able to access that data from there on free of charge based on the license, if it's the license is open. And then we said that, of course, sometimes it may not be possible to access it because maybe you have no information. Maybe that's one of the barriers that we have. You cannot access what you don't know. So the geo portal is there to tell you what is there. So it's like a place where you advertise all your goods. And then to sum this all, we use the fair data principles to be able to tell us that data must always be findable, accessible, interoperable, and reusable. At least for one thing that I'm sure is that yesterday we went away with something novel, something new in the GIS domain. So we only have one project in the world that at least that has embraced fair principles for the GIS domain, or the geospatial, or the earth and observation and geosciences domain. So for us here, we think that having this principle, it can be able to help us to be able to manage our geodata. So FAIR is basically a set of principles that allows us to be able to share data in a way that enables the humans as well as computers to be able to reuse this information or this data. And we say that FAIR means findable. The data has to be findable. It has to be accessible. It has to be interoperable. In other words, once you access the data, you should be able to integrate it and reuse it. And we say that this initiative is a few years old, not more than 8 years old. And the first publication on FAIR came out in 2016. And currently there is a lot of work on FAIR principles and how they can be applied in other domains. And we say that how do you know that your resource is findable, for example? It has to be documented, and the metadata has to be persistent. So in other words, it must be referenced using an identifier that will never break. So if you put it on the website, after 10 years, don't come and say that the data is not, rather the metadata is not available. Somehow it should remain there with a persistent identifier. And then we also say that, of course, it should be indexed. And then we should also have protocols that are open and they allow authentication and authorization. And the metadata or the data should, rather the metadata for the data should always be accessible, even when the data set is not available. That's what we said. And then for the interoperability part of it, we say that you should use a particular kind of encoding that allows you to encode some meanings of terms in the data sets, because different information sectors use different kinds of vocabularies. A person in the agricultural domain, trust me, will use a different kind of vocabularies compared to a person in the health domain. And then we also say that this data has to be reusable. So for it to be reusable, for you to know that your data is reusable, then you have to make sure that there is some kind of license so that the machines don't get confused about the reuse rights for the data. And then we say that there must be always detailed provenance information. So the provenance information tells us about how the data was created, the methods and the processes basically the data went through to be created. And then also it must subscribe to the relevant community standards. And we say that there are ways how we can find out how far we've gone, how far our organization has gone as far as being fair is concerned. And then we said that, we basically looked at the different links. These were basically the geoportals to be able to explore the data. And then we asked ourselves the question whether this data is well documented or not. And so that's what basically we did. And then later on, we went basically to the data infrastructures. So for the data infrastructures, we try to basically tell you that we have different challenges here in the country, and the only way we can solve them for data collection, rather for data sharing, the challenges in data sharing, the only way we can solve them is by using an infrastructure that provides a reliable environment for us to be able to share data. And we say that if we don't share this data using an infrastructure, this is what could happen. You could find that maybe you typically don't have you typically don't have different data set. Rather, in your planning, of course, when you execute these projects, they may never connect with each other, and maybe this could mean big losses. And then we also say that a spatial data infrastructure is basically a coordinated series of agreements. So institutions that are participating should have agreements on technological standards. They should have institutional agreements on policies. They should have policies basically to allow them to be able to share this information, and they can be able, so they can be able to discover it and use it for the information other than what it was created for. So we say that basically to have an STI, you must have a communication network. So those are the geoportals that we're talking about. And then we say that this geoportal is a one-stop gateway. It's like a marketplace. You are the producer, you put there your data, and then the user is able to come and access this data.
I told him.
You put there the metadata, basically, not the data.
I'm not going to cheat.
The user is able to come and be able to tell whether this data is useful for him, and then contact the owner of the data, and then be able to access that data in some way based on the conditions of access or the licenses. And we say that basically those are the communication networks or the network services. And basically in the geospatial web services world, we call it the catalog, rather the catalog service for the web. So that's one of the standards that's implemented for this metadata catalog. And then we need to have an information policy. We need to have a legal framework. We need to have metadata, just like you saw those tins, the one that was having an annotation and the one without an annotation. So we need to make sure that we annotate our data also, so that we can be able to discover it and then evaluate it, and then we can be able to access it later on. And then we need to have the data sets. We talked about the fundamental and the thematic data sets. And then we need to have standards governing all these things that are technical. And then we need the people, and then the institutions. And then we say that literally what you see of an STI are the policies that may be written somewhere, and then the information, rather legal framework. But then what you interact with is usually the geoportal that is basically leading you to the data that's being advertised by the metadata. And then we say that what it's trying to do is it's trying to basically imitate this kind of analog metadata catalog. And so that's what basically we talked about. And then we said there were different barriers to data sharing. We categorized them between technical, semantic, and organizational issues. So that's what basically we said yesterday. And then we said that there were standards, and these standards govern our, they govern basically our implementations in the GIS domain. So yesterday, we left off when we had said that it's very possible for us to document our data. And so I told you that today I'm going to come with a small metadata document so that you can be able to look at this. I've edited this metadata document. So this metadata document is for health facilities, but I've edited it, and so it's hypothetical. I've tried to make it a little bit hypothetical. It's not like a true metadata document. So don't take it word for word, but just get to see how metadata is being documented. So I said that if you have, for example, a health facilities data set, or my friends here may not understand what I'm talking about, but I'll try to add data for health facilities, for example, for our country here, so that you can be able to, possibly you'll be able to understand what I'm talking about. So assuming you have a health facility data set, just like this one, and you just very well know that when you have this data set, of course, if you open the attribute table, you'll see, of course, these columns. But of course, you'll see that we have the grade of the health facility. We have maybe whether the ownership, we know what the capacity is. We know, for example, the distance. We don't know what this distance is exactly, but we know it's just distance. And then we also know that, that we have the county name, the C name, and then we have, for example, the sub-county name. So, of course, for Uganda and some of these things, you'll easily understand them. But of course, you might also be Ugandan and you don't understand them because these columns are not really defined. The kind of vocabulary that they use in the health domain is a little bit technical. So for example, what is the health center 3? So it's a grade, but then what is it? So in case you get data and you just look at it from the first value, it may be a little bit complicated to understand it. So the first thing that you need always to do is to make sure that you get to the catalog and check. You need to make sure that you always check okay, I tried to look for it somewhere. So this data has been put on your Google Classroom. So you can always open it and see what basically it entails. So if I open this, oh no, just need to right click and go to item description. If I open this, you should be able to see, this is basically the metadata that was provided. This metadata does not, for example, I don't know, my friends, do you understand these things? Or you're just seeing some words? But I assume that maybe you understand to some extent, but not fully. Because for example, they don't define for you what a health facility, health center is. You know that, is it a clinic? Is it, what does it have? Of course, here we have our own language that we use. For example, we say that health center 3, rather health center 4 has maternal services, for example. That's what makes the, maybe, and some other services, maybe laboratory services and whatever. So that's what maybe makes it a health center 4. So all these things are not documented here. So, and then the other thing is that you don't know when the data was collected. Maybe, no, it was collected in 2021, 2011, but you don't know how it was collected. My friend here yesterday was saying, how sure am I that it is even accurate? Whom can I contact in case I have questions? So those are some of the things that you have to think about. So that's why I provided you with this small metadata document so that you can see how we document data sets. So for example, you need to tell people what the data set title is. So for example, you can say these are health facilities for Uganda in 2011. Already we have those ones of 2020. I've not displayed them here. But the interesting thing is that when we tried to compare them with a colleague, he said all of them are the same. And he said that because he could not be able to compare them, there was no metadata. So you need to make sure that you document these data sets so that you can be able to compare between them and then also be able to evaluate whether it's important to use. So we also had the abstract. So the abstract tells you the context in which the data was collected. So here the facilities keep on changing each and every year. And so they have new players coming into the market. So they need to basically update these facilities. And others change, they're upgraded, for example, from a hospital to a referral hospital or to something else. So, or maybe from a health center to a general hospital. So you need basically to map so that you can be able to capture this change. So that's why, for example, they were doing this kind of mapping. And they were using the master health facility list to be able to try to get the mapping. And then these are the keywords. And then also we have basically the temporal extent. For example, this was collected in 2011. The revision date is not known, but if it was known, you'd put it here. And then the reference date, maybe when was this metadata collected, rather created, maybe we can say today. That would be maybe the reference date. And then also the point of contact. So they need to tell you, for example, whom should you contact in case you want to ask about this metadata. At times you want to even establish whether this metadata has been, the person who created it maybe understood the context very well. So maybe you want to ask for more information. And then the language, the data is in English, as you saw, those columns were in English. And then also we have the topic category is basically health, and basically it's for Uganda. And then for us in the English world, we use the UTF-8 character set, and the metadata character set also is UTF-8, meaning that we use our characters start from A up to Z. We don't have these umlauts or letters. We don't have these special characters. Ours start from A up to Z, so that's why I'm using UTF-8. Now, you can see that there are access constraints. You need to put there the access constraints. For example, is this data free? So we say that the data is free of charge and it's obtained formally by applying through the permanent secretary of the ministry. And of course, we say that basically the license is Creative Commons. And this is basically the license that we chose. Yesterday, I sent you a link to all the licenses. And the constraints here, what this license basically says is that that the data remains the full property of Ministry of Health and can only be accessed through the point, or rather the contact points. It can be reproduced. It can be rather redistributed, so long as you acknowledge the work of the ministry. And the ministry does not assume any responsibilities in case you try to change this data or in case you use it and something goes wrong. So this is basically a license statement that you basically put to your data. So if someone ever uses your data and it doesn't acknowledge you, you are free to have, rather to invoke the implications. And then we have basically the, we have the data set responsible party. So there is a person who is responsible for this data set, as maybe a producer or as a distributor or something like that. So there's that information there. And then we have the spatial reference system, the format. You can get it as a CSV, but also you can get it as a shape file. And then we have basically the lineage information. So they tell you basically how this data was collected and what they collected. And then they tell you, for example, they tell you, for example, how they designed the forms and basically how they made sure that this data was availed to, rather was produced. So this is basically the lineage information. And then there is the quality information. So with the quality information, what happens is that you have to tell to what extent is your data, I mean, the quality extent. For example, you want to say that we picked using a handheld, so the spatial accuracy was plus or minus 10 meters. So this is basically an example of a metadata document. So what happens to this document once you've created it this way? In this column, the first column, you realize that we have what we call metadata elements. These elements are defined by a standard. You don't wake up and say, "May I have my own English?" And maybe you create your own elements. It doesn't work that way. You need to make sure that you you get these elements from the ISO 1915 standard or the ISO 19139 standard. And then you can be able to use them to document your data sets. So most likely, you should be able to realize that creating a very good metadata set, metadata document, needs you to understand how this data was collected and maybe all the information about the data. You don't just document what you don't know. So in other words, most likely the producer or the responsible party is going to document this data set. Most likely, it's not you because you found it without metadata and then you try to document it. That's not a good practice. You let the owner try to document it. And you as an expert, when you collect data, the first thing that you do before you start distributing it, getting excited that you have data, please make sure that you document it. So this is how basically you document it. So how do you put it basically in the shapefile so that it appears there? You have to open your software once again. So I'll try to close this. You have to open your software once again. And then you go to the layer, you right click on the layer, you go to the item description. So of course, before you do this, yesterday you remember that we went to customize and then first made sure that we set the standard. We went to metadata. We made sure that we first set the standard to ISO 1915. This is the metadata standard. Alternatively, we can use the 139. But it's okay. Let's use the 115. It's the most commonly used. For us here in our country here, we don't have, you see, we are choosing North America. Those guys sat down, they went to the standard, they picked out what elements were important to them. For us also here, we need to sit down and do that, but we've not been able to do that. So that's the hitchback that we have. So somehow we use some others' profiles. So you need basically to set the profile, rather the standard that you're using, and then you come to the layer, go to item description. I'm also going to illustrate what happens in QGIS for those who have QGIS, so you don't have to worry. And then all you need to do is to come here on the edit, and then you copy this, for example, the summary. You can come back to your metadata document. You can come back to the metadata document and moment. And then you pick this, you copy. And then you go to your ArcGIS and then you paste. You come here and paste it here. So for example, if we saved, you realize that something comes. So if maybe someone opens this data in future, then you can be able to know how the data was, what the purpose of the data was. And you do all that for all the other elements here that you see. So that's how basically you document the data set. But the caveat here is you can't document what you don't know. So you document what you know. So that's why maybe I don't have like a typical exercise to help you document a data set, just because I'm not sure whether this is even the metadata for this health data set. It's just a hypothetical data set. So you just need to basically, whenever you create data, just know the process. You need to make sure that you create your metadata, just like I've shown you here. And then you get to the to your, you get basically to your shape file, right click on the shape file. And then you go to item description. And then you edit. And then you can place your metadata accordingly from your Word document that you had created earlier. So that's how basically you add metadata. Now, what happens if, for example, you're a data manager and someone gives you data and the data is not documented? The first thing that you do is tell him, take back your incomplete work. In fact, that work is not good for you even to take on, because if you take it on, what happens is that it's not going to be useful after maybe 10 days when your memory maybe cannot still remember the context in which the data was collected, or maybe whom to contact. So you're going to get stuck with some dummy that you cannot be able to use anywhere. For those who use Quantum Gis, you need basically to just go and open your Quantum Gis. So I'll try to use Quantum Gis here. I already sent a link on the Google Classroom for you to be able to download Quantum Gis. So in case you've not downloaded, please, you can start and maybe we can catch up with time. So all you need to do is to get your data. So of course you browse to where your data is. So you have to browse where your data is, and then you can be able to use, you can be able to search for your data. So I'm able to add my data. Now, for Quantum Gis, what you do, you have to double click. You have to double click this data, or you have to go to the properties. You go to properties, and then you'll find something like this. If you click on information, this is basically the metadata. As you realized the other time, there was nothing so much. So you basically need to go to, once you find that this metadata is not documented, you need to go to, there's a tab down here that's called metadata here. So there is this tab here. You need basically to click it, and then you can be able to populate everything here. So interestingly, these guys have already created the software and rather using the metadata tab using the ISO 1915. So you just basically go to these tabs, and then you can be able to select, for example, select the appropriate, rather put there the appropriate information. So you can always add as many tags, for example, and then also how to access it. You have basically to state basically the license, how you're going to, so you basically bring all that information about the license, and then you can be able, this information, the access constraints, and then you can be able to paste it inside here. And once you paste it there, you have to save, and everything will be okay. So our take home for today is you're going to, you're just going to find a data set of your choice that you're familiar with. And then using this template, you can be able to develop metadata. So that is basically going to be it will be one of our outputs for this pre-conference workshop. So you make sure that you submit that, and then we get maybe whatever you're supposed to get at the end. So that's how we shall be able to grade you. So you need basically get data, and I'll make sure that I make these instructions very clear on the Google Classroom and in email. So you basically go and pick data that you're familiar with, And then you create a metadata document and then go to the software and paste this information there and then send. I don't know whether that's very clear, but in case it's not clear, you let me know. And I'll also send instructions on the Google Drive, or rather on the Google Classroom. So do you have any questions as far as metadata is concerned? Yes. Yeah. Okay. So someone is asking that for the benefit of others, that you tell us your name and then the question.
My name is Faustin from Rwanda. Faustin Gashakamba.
Okay.
From Rwanda.
Okay.
University of Rwanda.
And then the question.
These instructions, the demonstration was using Atma, but in case someone doesn't have access.
Okay. So Faustin is asking whether Faustin from Rwanda is asking whether the instructions for this practical will be ArcGIS or Quantum Gis. And I'm saying that you can use any software of your choice. The only preference to ArcGIS is this. ArcGIS, the metadata is documented in XML. And XML, you know that it's lingua franca for, it's a common language for documenting metadata and also transporting data, storing it. So it becomes very easy to read it in multiple software. Quantum Gis, on the other hand, you can document the metadata, but it's not yet like, it's in QML, it's not yet in XML. So that's basically the hitch, but still you'll be able to read the metadata, no problem. So I'm waiting for any questions online in case they are there so that I can be able to, so please let me know. So someone is asking for the link. I'm going to share the link for the classroom, or maybe Arthur will help me and share the link for the classroom. So allow me to start something new besides this metadata thing and the catalogs and being able to discover and be able to evaluate data. Allow me to get to something that is called the OGC web services, so to be specific. Of course, previously what we've been dealing with is basically the we've been dealing with the catalog services for the web. You saw that interaction diagram. How do you access the web portal? How do you basically check on the metadata? How do you basically evaluate it? So that's what basically we've been doing this yesterday and this recap. And those links that you're seeing when you get to the metadata portal, you're basically dealing with the catalog service for the web. Everything in that metadata portal has been implemented using a specification called the catalog service for the web from the OGC. And this catalog service for the web, it allows us basically to publish data and be able to access, rather publish data or even metadata, and then be able to access the be able to find, search and retrieve metadata about data or even data itself. So that's what basically it helps us do. So for now, we are going to have something new. We are going to look at other web services. And we have basically the web map service, just for us to have just a short, for you just to understand particular terms. So at least if you don't understand something in this session, understand these few words. We're going to have services like the web map service. People call it WMS, they abbreviate it as that, web map service. And this basically allows us to be able to access data from the web as though it is a picture. That's it. And then we're going to have the web feature service that allows us to access feature data. Other people call it the WFS. And then we're also going to have the web coverage service, and then the web processing service. So once again, web map service, web feature service, web coverage service, and web processing service. So that's what basically we're going to tackle. At least if you don't understand everything, just understand those three, and maybe you can be able to search about them in future. So yesterday we talked about interoperability. We talked about how do we make sure that we share information. We said one of the barriers that we have is the technical interoperability. The fact that I want to share data onto your computer, but then the protocols maybe don't allow me to share that information, right? Now, to be able to solve these barriers, we have what we call the concept of web services. So the web services basically provide us with a way how we can be able to share this information over the internet. So the thing is that, the concept here is that, why should everybody keep data on his computer? Of course, that's not very logical. For us, we think that with the web services paradigm, we think that this data should be kept in one server, and people are given a link and they can be able to consume it. So you have it in one destination, but thousands of people can be able to consume this data. So I just imagine the Regional Center for Mapping is the only one that is hosting this data. It has it in its database, and then it serves it as a web service, and then everybody can be able to access it in the whole of East Africa and without any hitches. So that's basically the concept of the web services or the distributed services or architecture. So just like we said that these web services allow us to be able to share information using well-defined service interfaces to ensure that sharing is very easy. Now, the idea is that you want to have effective organization of geodata. So you basically want to have this data organized in one place, and then other people can be able to access it using a link. Now, putting data in a server does not mean that everybody can be able to access it. There must be a well-defined set of specifications that every person must know. For example, if you're a GIS expert, you must know that if someone gives me a link, this is how I can be able to access the data. So there is a specification that basically states how you can be able to access the data. It is in a particular server. So in other words, there is some kind of a defined interface for you to be able to access this data. So the idea here is to consume and not to store. It's very interesting that most of you have laptops here. Maybe you could be having all the data that others have. Now, for us, we're saying, no, this shouldn't be the case. This data should be in one server, and then all of you are given links, and you can access this server simultaneously with ease without having any hitches. So in other words, you reduce redundant data storage, because in this case, you have a one-stop center where the data is stored, and then you can be able to access it using specified specifications or a standard. Now, of course, this data can also be accessed and even styled or even presented using well-defined structures. That's the interesting thing. In some way, we have some kind of transparent storage. So web services allow us to be able to distribute this information via a well-defined service interface, or maybe interfaces. Now, how do we even achieve that? How do we make sure that we achieve that everybody can be able to get this information via these interfaces? First of all, it's based on an open architecture. So we call it the service-oriented architecture. And in this architecture, basically, there are so many best practices that they use. So for us, the best practice that we actually use is the publish, find, bind. That's what they use for the catalog. Of course, there are so many other best practices that they use. So many, more than 160 that I've seen. So for this particular kind of best practice that is used, it's basically based on the SOAP architecture or the service-oriented architecture. And basically it utilizes standards from the W3C consortium. That's the World Wide Web consortium. And the Open Geospatial consortium, OpenGIS consortium. Now, how do they make sure that they achieve this interoperability and they gain independence? The way they do it is that, first of all, this web service should work on any operating system. As you shall see, even on your phones, it will be able to work. You'll be able to get these maps from the internet. You should be able to use it, whether it's a programming language or it's a client, any interface should be able to access it, so long as it can be able to get HTTP protocols. So that's how basically it gains this kind of independence as well as interoperability. And of course, so I've already talked about this development environment, so many environments. That's why you see, we can have these web services incorporated into our web maps. We can have them incorporated into our clients. And today we want to start with the easier one. How do we incorporate them, for example, into our client applications or maybe GIS projects in the client? And then tomorrow we can be able to see how basically we can be able to incorporate them on the web. Now, I've talked about web services, and some people maybe have never heard this word. So we want to actually unpack what a web service is. Whenever we talk about a web service, we are meaning any software that basically utilizes itself or maybe is operating on the internet and uses XML as the message transport system. So in other words, the data is stored using XML and transported using XML. So XML is basically a format. And the reason why we use XML is because it is text-based, so it's light. It's not like a shapefile, for example. A shapefile is if you had sent someone an email of a shapefile, it's going to be very heavy. The size as compared to an XML document is basically heavy for a shapefile. So, and XML is widely understood by everybody. And most of you have used XML in one way or the other. If you've been playing around with your social media, you should be wondering how information comes from wherever you send it from, rather from other place to another, how your colleague sends you information. You basically get it as XML messages, but then it is displayed as displayed in a structure that is legible. So XML basically standardized and allows you to be able to store and transport data from one destination to another. That's what basically XML does. And it allows you, first of all, this language is understandable. Even if you're going to look at it, it's just when you look at it and you look at the tags, you easily understand the document. And like I've told you, it's lingua franca. In other words, everybody uses it and it's a standard, it's widely accepted. Now, it allows you to control which information should be presented. And then also it's very possible for you to have this, it's very possible for you to encode multiple coordinate systems, multiple formats. It's very possible because with XML, you can be able to drive other languages that are used in the geodomain that we shall see, for example, the web feature service. Now, with a web service, what happens is that we have a best practice that we use. That's the publish, find, bind. So what happens, there are many standards around this publish, find, bind paradigm. So you see this triangle here, that's what I'm trying to say. You have a registry. When you publish your web service, we shall see, tomorrow we are going to publish our own web services for the first time, maybe for some of you. Others have done it before. if you publish your web service, you need to basically put it in a registry so that people can find it. You don't publish for your own self. That's the reason, the reason why you're actually creating web services, because you want to share, to distribute your information. So basically you have prepared this, rather publish, and then put it in your registry, which is basically compliant to a particular standard called UDDI, Universal Data Discovery and Integration. And then this web service is basically described using the web service description language, which is the WSDL. And now, when you want to use this web service, what you have to do, you come to this registry, which is like a catalog, and then you're able to search, and then they will tell you we have these services, and then you can go and pick the services and then be able to use them. So you do the binding, and the binding is through the SOAP messages. So that information will be sent to you as though it is XML, for example. So that's how basically the web services basically work. Now, of course, I've spoken a lot, and I need to maybe put it in form of a picture. So what I'm just trying to say, assuming you have your data somewhere. So you have your data here, and this data, for example, is about water quality, or it's about topographic information, or maybe thematic information. Now, we have a server, we have a software that sits on top of this data. So this data could be in a database or in a folder. So what you have to do is to publish this data through that software. And so in other words, you have a server here, and you can say, okay, I'm going to publish my data as WMS, WFS, or you can even publish algorithms that are supposed to process the data. So you basically place them in this software that we shall see. So basically you have the services here. And then you can create, for example, a water quality service. And people can be able to invoke it and be able to utilize this service, and that's it. Now, on the client is maybe the web browser or your ArcGIS or Quantum Gis. What you see when you request for this service is basically the data or maybe the process that you can be able to utilize to process your data. So as a user, you basically have a link that you're given, and then you can be able to access data that is on, for example, we used an example of regional center and mapping. You have basically data on their servers. So throughout this whole exercise, you'll allow me to use one of their services so that you can be able to understand. And then later on, we can be able to go to other services. Now, of course, they'll have this data on their server, and then they have this, they publish their services, and then you, the client, on your computer, wherever you are, anywhere in the world, so long as you can access the internet, you should be able to access that data without having it on your computer. So the idea here, once again, is we encourage publishing, rather we encourage consuming as compared to storing. And we do it over well-defined interfaces. So that's basically the big thing that you have to capture here. Now that's about web services, but in case you have any question, feel free to ask as we progress. I'll be able to see this question, or you can maybe come through, just raise up your arm and then ask as we, so that we can capture it in real time. Now, there are, of course, various specifications from the OGC. These specifications, of course, standards also. They have been converted into ISO standards. So we say that at least at the end of the class, if you don't understand something, at least understand there is web map service, web feature service, web coverage service, and web processing service. We have so many other services. For example, the catalog service for the web, we've already dealt with it actually. That one, we've done it actually in detail without first announcing that we're doing it. And then we have the sensor observation service, the sensor alert service, so that these services that allow us to be able to deal with sensor information. But for our pre-conference workshop, we're just going to work with the web map service, web feature service, web coverage service, and web processing service. Now, how do they work? So I put this picture here so that you can be able to understand how they do work. Now, the web map service will only allow you to be able to get data from a particular server using HTTP protocols, the get and post, to allow you to get that data in that using those protocols. But the data you're going to get is going to be an image. That image, you can overlay it on your maps, but you can't use it for analysis. Neither can even, if you try to download it, you just get an image without a coordinate system. In other words, the aim of the whole big deal of having this WMS or web map service is to advertise your data. Maybe the best example I can give you is Google Maps. Can you get that Google Maps base map and be able to analyze anything on it? I don't know, but I think it's not possible to start doing analysis using Google Maps. The best thing you can do with it is just overlay on top of it. The moment you try to become a little bit brilliant and say, I'm going to download this data so that I use it later on, it's not possible. The server will not allow you. You'll just get a PNG or an image that cannot be useful for any GIS analysis unless you try to georeference it again. So that's what basically this web map service does. Now, the web feature service brings you feature data. It's not a shapefile, but it's feature data. So it's a data that a shapefile is also feature data. But this one brings you feature data that you can be able to, for example, right-click and in a client GIS software and be able to see an attribute table, as we shall see. Now, the interesting thing is that this data comes as though it is GML. When it is coming from this server, it comes as though it is GML, geography markup language. It comes as though it is text, in other words. But once it gets into the client understands that this is actually a shape data and then converts it into shapes. So in some way or the other, it's a little bit easier to deal with. Then we have the web coverage service. The web coverage service is almost like the web map service, but the difference here is that it will bring you a raster image, but this raster image, you can be able to toggle through it, you can be able to use it for analysis. You can be able to play around with it, you can be able to get derivatives. For example, if you have a digital elevation model being served as a web coverage service, you'd be able to use it to compute, for example, slope. Now, with the web map service, on the contrary, for it, you just get a picture. You cannot do anything with it. The best you can do with that thing is just to overlay other maps on top of it. But with the web coverage service, what you get, you can be able to put once again, there is a standard that's already existing. Of the standards that I showed you, there is one, I think it's ISO 1918, rather 128. What this standard basically does is it specifies how this web map service should be implemented. You don't wake up and become so excited and say, me, I'll do it my own way. No, these guys have already specified how a typical GIS expert should be able to publish and consume these services. Now, a web map service basically specifies the behavior of a service that produces spatially referenced dynamic maps. And of course, this is basically geographic information that we're talking about. And basically, what you can be able to do is to retrieve a map. And of course, it's very possible to retrieve also the description of the map that's being offered by the server. So what happens that in the first instance, once you want to communicate to this server, once I've given you the link, the first thing that you have to do is to ask the server, what are you capable of? So for us, we call it a get capabilities document. So you need basically to tell the server, I need the capabilities of the server. So that you need basically to ask the server to tell you the capabilities. So the server will respond to you and tell you, we have this data, it's in this coordinate system, maybe it's of this extent for this area, and these are the formats that you can be able to access the data. So that's basically the capabilities document. We're going to see it just shortly in the next slide, so that you can be able to put in your browser and see how it looks like. Now, once you already know what the server is capable of giving you, then you are at liberty to ask the server to get you now the map. So you ask the server, can you get me the map? So you retrieve the map. And that map, like I told you, it has a spatial reference system. But the moment you download it, it will become just a picture. The best you can do with it is just overlay other layers on top of it. So when you query the server, it basically brings you first the capabilities document, which is an XML document. And then later on, it will bring you an image if you want the map. So it does not bring you actual feature data or coverage data. So if you try to get to the check the pixel values, most likely you may not be able to be successful. So that's basically the problem of this, the limitation. And I've told you the reason why I would use, for example, this web map service is to make sure that I just portray to you what I have, I just advertise to you, but I don't want to give you, for example, Google doesn't want to give you all those nice satellite images. So what it does, they just portray and then show you, this is the data that we have, but we can't give it to you. Just look at it, it's very beautiful. You can use it for overlay. In case you want it, you have to contact us. So that's basically what they're trying to tell you indirectly. Now, I've tried to utilize one of the links from the Regional Center for Mapping. And of course, I'm sure you may be asking, what was the rationale for doing this? I checked in their catalog and I was able to retrieve this GeoServer. So I checked in their catalog, as we'll see in one of these other slides. We shall be able to check in one of these catalogs and see their services that are available, so that you can see that you don't just have to wake up from nowhere and then say, maybe you have to remember this link or whatever. This link is in a geoportal, the geoportals that we checked yesterday. Now, I told you the first operation is get capabilities, so that you can be able to know the capabilities of the server. Then it's very possible to describe a particular layer. So it tells you about a particular layer, information about the layer. And then also it's very possible for us to, once we know about the layer, we can be able to pick the appropriate layer and then to bring us that layer, so long as we specify the appropriate parameters. For example, if you have for the whole of the country, you can say, I only need this part for the university. So you specify basically the parameters. Or you could have the get feature info, try to describe them. These things are better done practically. So when you do them practically, maybe it becomes a little bit easier for you to know what these web services are all about. So now, there is something that's case sensitive there. The operation, which is basically, for example, you want to say, for example, the request, that one is case insensitive. But the value, the key value pair is case sensitive. So don't try to get capabilities the way you want. That operation is supposed to be written using get, starting with the capital and then in the middle with the capital for capabilities. So the moment you change this, you're not going to get any data. So maybe let me first now try to illustrate how this get capabilities layer works. So assuming I have this link, so I'll try to, so literally what you'll be given in the first place is this. So you'll be given a link like this one as a GIS expert. So as a GIS expert, you're supposed to understand that I'm going to request the server. So you need to request the server. Okay. I need to get this place so that you can be able to see. Can you please so please kindly click that link. I'm sure you have that link. You can use your phones. Like I told you, this is a platform independent. You can use whatever you want. So there is a link here. Okay, let me paste it in the chat. Adrian, I'm on another page, so kindly take me there. I'm on this. Let's share screen. Let's try to say whether we have, okay, we have this link here. So as a GIS expert, you simply need to know that once you're given this link, based on the existing specification, this link should take you to the data. You should get to know what is in this server. So that's the link to the server. So for you, what you have to do is to basically come here and say, okay, I'm dealing with a service called, I told you this is case insensitive, you can capital letter or not. And then you have to put there equals. So if the service is WMS, web map service, you realize that I have a key value pair. So I just said service is equal to WMS. Now I need basically also now to tell the server the request that I want to ask it to do. So in this case, the request is, okay, I try to make sure that I want to make it a little bit bigger. So the request that I want to specify here, now you have to put there an and sign or the ampersand sign. So this sign here, and then you type the request. So for example, the request, and then you put there equals. Now you realize that the word request there, I've written it in how I want. You can also write it the way you want, but the operation has to be written the way it's supposed to be. The operation is get. I want now to ask the server, what do you have? I want to know what the server basically has. So it's get capabilities. So when I ask the server, what do you have? So basically you've realized that I put there these two key value pairs, and I separated them using the ampersand sign. And you should notice that also there's a question mark before we start putting those pairs. So I'm asking basically the server, what do you have? Now, this one is not my own making. There is a specification that tells us to do this. So when you're a GIS expert, you have to know this, that this is how we get data that's already published using web services. So if I click enter, it will respond to me and tell me that this server has, of course, it will tell me all the information that they put in the server. It will tell me that they have data as though it is JPEG, GeoTIFF, and then it will tell me the coordinate systems that they support. It will also tell me, if we move down, I hope you've been able to, I'll try to be a little bit slow so that you can be able to access this. I've also created a tutorial whereby I've already put all these things. So you need basically to, so my friend, I've accessed your server somehow, but I don't know whether other people, you want people to access it or not, but the way it was done is the server has to be accessed this way. So as a GIS expert, once I know the server, I don't need to be helped. I just need to use the specification and then be able to access the whatever is in the server. So after this, we can go ahead and add other more, we can now go ahead and pick the data that is there. So for example, we shall see the data that's there. So for example, they have this, they have data about the lack of adaptive capacity. So we shall see this data. So this is how basically you get to know the capabilities of the server. Now, I told you that we have also another service called the web feature service, right? So for the web feature service, if you wanted to know what this server has, you just come and change this and put WFS. If you also press enter, it will bring you and tell you the capabilities of this server. And for the web coverage service, you have also do the same. So they're literally the same for all these, they're literally the same for. So the web coverage service, you also do the same. You just keep on changing this CS, rather the service. So what I'm just trying to say, once someone has data in a server, you can always know what is there by just getting the capabilities of the server. Of course, I know that this GeoServer is somewhere. It's if you try to delete until GeoServer here, you'll be able to see actually where the GeoServer was even installed. So for example, if I deleted until here and just clicked, so you'll see the GeoServer. And you'll see that actually it has these many services. It has the web coverage service, web feature service, web map service, the web map tile service, or the tile map service, and of different versions. And then if you go to the layers, you'll be able to preview the layers that are available. So when you're talking about those Malawi layers are actually here. So you can see the layers are actually here. And you can be able to access them already if you wanted. In the browser, so if you're doing web mapping, this is the link actually that you put in the web map. So something's still coming, it's just because of, I think it's a heavy thing. So you can see this is the layer from the server. In fact, also the web map, the get map capability, the get map operation basically brings the same thing. So you can run this in the browser or you can run it in the client software. So tomorrow we are going to have a whole session on how to run these things in the browser. So I'll be able to explain to you how to basically create a get map, a get capabilities, and so many others. For today, all I need you to do is to basically check this tutorial. When you check this tutorial, you realize that I put for you these same links. And I've told you that, so we're going to do this tutorial together. By the time we finish this tutorial, I'll just go back and explain the slides, so that you can, I'm starting from the end, coming to the beginning, so that you don't have to sleep and you understand it practically. So let's start doing this tutorial together. So we have basically these catalogs here. So for example, you have the RSMRD catalog, or you have so for example, if I open one of these, if I open this catalog here, I don't know what is inside. Maybe they have services. I'm not very sure. I don't know what this one is, but so they have a geo server here, and they tell us that this geo server can be accessed from here, but this one has issues, as you can see. So in other words, you just click on services here, or alternatively, you can be able to search for the services. Remember, we dealt with this geo portal yesterday, so that you can be able to see what is a service. I mean, which data is a service. So they'll provide you and tell you, they'll give you the link to the service. Now, as a GIS expert, my friend, you need to understand this, what this link means for you, and then access the data. In this same thing, we also have the FAO Metadata Catalog. So this is a global initiative. And in here, they also have their services. There are layers that have services. So for me, the easiest way I do it is just to type here so that I can check out what service, rather, for example, the WMS. So all these data sets have WMS. So if I check, you can see that this is the WMS. Well, I'm just illustrating this just to show you where to get these links from for the web services. That's the reason why I put those links. But apart from that, the tutorial already has, it already has those links. I've already gotten them for you. So the issue here is, where do I get these links to the web services? You go to the metadata catalog, go to the registry, and pick them. That's what I'm just trying to say. Why do you get data? You just go to this advertising site, which is basically the geo portal. And then they will tell you how they have this data, either as a shapefile or as a service or something like that. That's what I'm just trying to say. I don't know whether that's very clear. The idea, I don't know whether that idea is very clear. Now allow me to go back to the consuming. So I'm going to use, for those who have ArcGIS, please, you can use your ArcGIS. I'll also illustrate the same concept in ArcGIS. But for those who have Quantum Gis, I'm also going to illustrate it. So you just have to open your software. Just try to open your Quantum Gis. So I'll try to close everything so that I can open with you. So that I can illustrate the differences for these web services. So all you need to do is open Quantum Gis. For those who have not installed Quantum Gis, feel free to install. You just have to go to Quantum Gis download. Just type it in the browser and then you'll be able to get this software. So you just need to come here, say QGIS. This is free of charge. ArcGIS is bought. So I'm trying to use the free of charge kind of software. So you just need to come here to download QGIS, and then you basically choose what is very good for you. For example, you can use the standalone installer, which is more stable. And once you have it, you just double click on it and then you install it. So is everything okay? Okay. So once you have your Quantum GIS, then you open it, and this is how basically it will look like. It will look basically like this, and you have basically your panels. You have this is your main panel. For those who have seen, who are seeing Quantum GIS for the first time, you have basically this menu here that has all the functionalities. You can check, I mean, if you want to deal with your file, open it, or maybe save it. And then if you want to edit, if you want to view toolbars and panels and so many other things. So this is basically what you use. And so if one of your panels is missing, then you can always come here and incorporate it. Or if your toolbars is also missing, you can always come and incorporate it. And then all the other functionality, if you're dealing with vector data, is here. If you're dealing with the raster, is here. If you're dealing with databases, then you basically go to this menu. But interestingly, all these functionalities are available in the toolbars here, these icons here. And then also, if you want to access, please let me know if I'm fast. Let me know if I'm leaving you. This is an important part that I want everybody to do by hand. Then the rest you can go home and cram, but let us do this by hand. So this basically has all the algorithms, like the toolbox, the Arc toolbox, synonymous to this one. So this is like, if you look at GIS as a toolbox, you have your problem, okay. Just go to the mechanics toolbox, pick the appropriate algorithm, and use it, process your data, and then that's it. And then, of course, if you want help, you just come here. If you want to install plugins, so there are third-party applications. So Quantum GIS is modular in nature. So if you have maybe a new plugin that you want to develop, you can develop it and just incorporate it here, and people can be able to use it. So we are going to install actually an experimental plugin, which is called the WPS, Web Processing Service plugin. And then if you want to add layers, you add them from here. So you can create new layers. You can also add them from this. Now I want us basically to access, for example, how do you access a web service? So for us to access a web service, when you go to layers here, we say that a web service allows you to be able to get data from a server, right? So it allows us to be able to add data to maybe our clients, in other words. So this data, I'm not keeping it. It is kept in Nairobi, I think, in the servers. So we need to access it from there. So you say add data. So you come to add layer. And then it's very possible for you to come to the web map service. So you say add web map service. So this time you don't add the vector data, just whatever, just add a web map service. So you're adding data from the internet, if I would say it in a layman's term. You are getting data from some server, and for you seated here, you must have internet. So you don't do it without internet. So when you click this, I'm keeping this there so much so that everybody can be able to catch up. So you have to make sure that you add a web map service, web map tile, rather web map layer, or web map tile service layer. So what happens is that when I say add, This is what I get. You could also have gotten it from the properties dialog. Now, I'm sure yours are very empty. So you've not yet created any kind of connection. So we are going to create a connection for the beginning. So all you need to do is to click on there's something called new here. You click on new, you can maybe call it anything, maybe AGRC 2021 or anything, any name that you prefer. Now, you have to provide the link, the other link that I showed you that was for the server. I pasted it in the whatever. I pasted it in the Zoom. So I'm going back to look for my link, my friends. So this is my link that I pasted there. This link, we already have it in the tutorial. So that's why we already have this link somewhere in the tutorial. So the link is already here. So I get that link and I just come and I put it inside here. This new connection. Are we together, sir? In case we are not together, you let me know. Maybe I can, yes, please. The what? The link. Can I maybe, can you access Zoom? Is it possible to send me an email and then I just send, rather forward you, Adrian, help me and forward the email with that tutorial and the link. Yeah, there is an email that I forwarded of all this material. So you can give it to Adrian and he'll help you. So you put this link in you put it in this small dialogue, and then you say, okay, we're going to do it 3 times. That's the interesting thing. We're going to do it also for the web coverage service and the web feature service. So in case maybe you've not gotten this one, at least you'll be able to get it once we do it many times. So when I do this, it means that now I've told the other, I've just tried to specify the other server. Now I can connect to the server. I can connect to the server. And when I connect to the server, this is what it tells me. It tells me the capabilities of the server. It tells me these are the many layers that are there. And it tells me that I can be able to access them in any format. So these are the formats that are available. I can choose any format that I want to use. Now we need basically to access the layers. Now you need to specify the layer that you want to access. So for example, when I click something like the national exposure and I say add, it has already been added. If I become brilliant and I say I'm going to download this layer, the coordinate system is going to disappear. For now, there is a coordinate system. You can see when I hover, you can see that when I hover around, you can see the coordinate system, WGS84. Now, if I try to become a little bit brilliant and I say I want to download and also go and use it at home, or maybe I want to apply some kind of algorithm onto it, it's not possible, my friends, with the web map service. And if I try to basically open the attribute table, it is not there for the web map service. So what you can get with the web map service is just basically a picture. The best thing that you can do is overlay other layers on top of it. That's the best thing that you can do. Now, this maps can already be pre-rendered behind there. They can be styled. Now, like this map has been styled behind there. So I've used basically the styled layer descriptor is also a standard to basically style it. It's an XML kind of encoding to style this layer. So the layer is now styled and you can be able to access it. The best thing that you can do is overlay on top of it. I can try to get another, I can try to add maybe another layer. So I go back to add WMS and I can add the boundaries. Let me add the national boundaries and you see what happens. When I add the national boundaries, you see it overlays perfectly. And of course, you can always turn off and turn on. Now, if you try to get these national boundaries and you right-click them to get the attribute table, you see it's not there. Because it's a web map service, what you have here is a raster. It's not actually, it's not vector. And the best thing that you can do with it is maybe to create simple queries and say, okay, what is inside here? And then maybe to tell you what is inside there, but it won't give you the attribute table. So this is basically an HTML kind of pop-up. So that's what basically it gives you. The best can give you is just get info. Feature info. So you click here and then tells you the info about that place. It doesn't give you the pixel values. It just tells you the location and the info about that place. But the pixel values, you can't see them. So the most important thing for us here would be the pixel values for analysis. So in other words, you cannot be able to use it for analysis. Now I'm going to bring the boundaries layer using a web feature service. So I'm going to go back and to layers and do the same thing like we did for the web map service. So you say also add layers. So you just come here now, there is something like WFS here. If I click on WFS, also it will allow me to create a new connection. Maybe let me call it AGRC. And now I need to put here the URL that I gave you. And then I'll ask the same server to connect. And then it should be able to tell us what is there. So it has this national boundary actually. It has the only feature service, rather feature layer, it has the national boundary. It doesn't have so many other feature data sets. If you basically have this feature data set, now you see it has possibilities with the web feature service. It's like as though you're querying, you can be able to query it actually if you wanted. And say maybe I need only particular districts or something like that. That's the possibility. There are so many things that you can be able to do, but let me just add it the way it is for now. If I added it, you'll see what it is looking like. Do you see this one? Let me first close this. Do you see this one? This is a WMS. The one that we first brought. When you try to right click on it, or rather when you look at it actually, on the side here, you see that actually it is a raster. WMS brings a raster, that's what we said. If you become brilliant and you say, I'm going to download it, problems. You will not see the coordinate system. For now, it has it because it's in the client. The best thing that you can do it, rather use it for is for web mapping, overlay, and things like that. Now with the web feature service, for the same layer, it has brought feature datasets. In fact, I can play around with this one. I can even edit it. I can play around even with the symbology. That's the interesting thing. I can play around with the symbology or whatever I want to do with it. You see? I can play around with it. Let me close this and you see. See this? Previously, it was just any color. So rather it could have been orange or something like that. Maybe I'm colorblind, I'm not sure. But it was like orange. So what happens that if you right click on this web feature service, you realize that it is going to bring you a table. it has an attribute table, right? In fact, you can even go ahead and say, I want to download this layer. I want to export this layer and save it somewhere. And when you save it, you'll get a shapefile or maybe the format that you've specified. Let me try to do it and you see what happens. For example, I'll try to create something here. And then I create a new folder here. If, for example, I try, I hope we are going to do this together. We are going to repeat it again and again, maybe other 3 times, to make sure that all of you can be able to do it. Once you can be able to do it, I'm very sure you'll understand these web services. So the slides at least will be able to complement. So you can be able to save your data, for example. So you can be able to save this. This is stored now in another folder. It's very possible. And in fact, you can be able to, for example, I'll try to remove it and I'll bring it later on, as you'll see. I'll bring it later on after I've closed everything. Now let's get this same boundary. The same boundary also, that's basically a web map service. So I'm going to save boundaries, but WMS. So I'm going to export it, save as, and then export it to be GeoTIFF. So if I click whatever was created here, okay, this was the format that maybe I specified. I need to go back and re-specify this format again. So first of all, even downloading is becoming a problem. So maybe let me choose and let's choose the format, one of those formats. Maybe JPEG. Okay, maybe let me just leave it at GeoTIFF. So you can basically come and maybe give it something like WMS as the name. So it has refused that even to write it. But in case you ever even got it, you can be very sure that's going to be just a picture with no coordinate reference system. But for the other one that we saved for the WFS, it was very possible for us to save it. It was very possible for us to save. Maybe let me differentiate the color so that it becomes a little bit easier to. So this is basically the WFS, and this is the WMS. So it becomes very difficult for us even to handle the WMS, but the WFS, we can even be able to go and search for this layer wherever we stored it and be able to get it. So as you can see, we have for the shapefile, and we have this. This is even having issues. Now, what I'm just trying to say is that WMS allows us to be able to get maps, which are just rather pictures. You can overlay on top of them, you can play with them, but you cannot download them and you expect to see a coordinate system. And the best thing that you can do with them is to get, for example, the feature info. For example, you can say, what is the feature info here? When I click here, it will tell me the feature info, the information about this polygon. But it doesn't tell me, for example, the pixel values. Since it's a raster, we're expecting to see pixel values. It doesn't. So that's what basically that's how WFS is different from WMS. I'm going to repeat this whole thing now. Let me try to repeat it again. So I'm just assuming I want to access data from a server. I can access it as a WMS, WFS, or WCS. With a WMS, that's a web map service, and I can get just a picture where I can overlay my other layers on top. But I cannot be able to download it and have anything, rather anything about it. With the WFS, I can be able to download the data and actually even use it for my analysis. It's very possible. And with the WCS, I can be able also to download this data as raster data and be able to use it. That's the web coverage service. So what I'm just trying to say is, in our tutorial here, we say that if you wanted to access this data, just go to add layer. I'm not getting any feedback from my Zoom people. Please let me know. Okay. Please. Okay, Brian.
Yes, Alan, can you hear me? Hello?
Unmute Brian. Yeah.
Hello? You can hear me, eh?
Not, okay.
Hello?
Yes, Brian.
I can hear you. Can you hear me?
Yes, I can.
Yeah, so I was saying, yeah, we are following. I just had one question. The WMS, can you be able to, for example, can you be able to, for example, create a map out of it? If you just overlay, then you go to the composer and just create a map for use. Is it possible?
Yes, it's very possible to create a map out of the WMS. What happens that it comes already when it is tiled. There is nothing much that you can do about it. You just only overlay, you go to the composer and then maybe create. So I can maybe explain it. So you come to the layer, add layer. And then if you come and say add WMS layer, so we already have our layers. So you can create a new connection, but if there is one that's already existing, then you can always utilize that. So for example, if you come and say, you can overlay actually even several of them. So you can come and say, if I add this, I'll get something here. If I add the boundaries, this is what I'll get. So you have something already. So it's a map that's already created, already predefined, pre-styled, and it's very possible for you to actually go to the composer and create a new print layout, for example. It's very possible. So it's very possible to do that.
Okay, but can you add coordinates?
So in other words, you don't change anything as far as the styling is concerned, but you can be able to use the maps, you can be able to overlay them, and that's it. And of course, this is one way of accessing a web map service. We are using basically a client like Quantum Gis or ArcGIS. There is a possibility that you can be able to use other clients. For example, you can use the browser, Chrome, Mozilla, you can use, like I've said, it's because it's XML based, you can be able to run it on any platform. It's platform independent. No operating system is going to be an impediment. It's just going to be platform independent and operating system independent. Okay, so I'll close this and maybe go back to, I can get the data as though it is a web feature service. So I said you just have to go to layer, and then you say add layer, and then you say add web feature service. But now let me do it for the web coverage service, which we have not done it for. So it's very possible for you also to add a web coverage service. You'll see the difference between a web coverage service and the web map service. The web map service, for it you can get feature info, but you can't get the exact pixel values. You will not get them. So we shall create our new connection, and then we have our URL. So notice that there is a question mark at the end of the URL. So that's why you start defining all your key value pairs, as we shall see tomorrow. But for today, you just need to carry, get a URL up to that question mark. Now, for servers that have keys, you might have to put the key there. If you don't put the key, they will not allow you to get the data. So some servers, they have keys already. But this one is an open server. Now, whatever you put here is up to you, the name of the connection. You put anything, it will still work. So for example, I'll call it AGRC WCS. And I say, okay. I don't know what is inside this server. I've not yet tried it before, but let us connect and see. I think there is something. So interestingly, all the layers that they give you as a web map service, they also give them to you as web coverage service. So these layers, you can actually use them to do analysis. You can actually add them in, for example, in a multi-area evaluation and be able to make sense out of them. It's very possible. So for example, I'll get this same exposure layer and then I add it. So I've added it. As you can see, this is how it comes. It's the same layer. It's this same national exposure, but now this one comes as though it is a real raster with the pixel values. And actually, if you click here, you'll see the pixel values and the bands, not the feature information that we are seeing before. And in fact, you can actually get this and export it, and you'll use it later on. And you can also analyze it. You can get algorithms, and then, for example, you can apply some algorithms onto it, and then you're able to derive much more information out of this layer. I can also visualize it. They give me all that, they give me that leeway. So there is a possibility for me to play around with it because it has values in it. So as you can see, you can make it look the way you want it to look. Now, once again, there is a possibility for me to, for example, you can see all the pixel values. There's a possibility for me to be able to use it in a client, rather in any other algorithm. Try to analyze it. It's very possible. On the contrary, the same layer, this same layer, if I clicked it, you will see that okay, it just gives me feature info. It just gives me feature info. It doesn't give me those band values, the pixel values. And I cannot be able to analyze this. I cannot save it. I cannot do anything. I cannot. In fact, once I got out of this client, it will cease to have a coordinate system for the web map service. So to summarize what I've been talking about, I'm just trying to say that with a web map service, what you get is a picture. The best thing you can do about it is overlay. And you can have this picture already when it is pre-rendered using the style layer descriptor. With a web feature service, what you can get is actually feature data set, rather features. So what you have here, for example, for the, let me try to get the web feature service. I go to layer again, add layer, I go to web feature service, and I connect to this one. So I can add what you have here added is basically, let me close this, is basically a feature data set. These are different polygons. And if you got these polygons, if you wanted, you can actually do analysis on it. So that's the beautiful thing about this. So let's distinguish between two things. There's what we call a data service and a portrayal service. A web map service is a portrayal service. Someone just wants to show you his data. You can only overlay on top of it. So if maybe you have your data, you don't want to give it to anyone, you can just publish it as a web map service. People will access it, they will know it is there, they can overlay on top of it, but they can't use it for analysis. And if you want to give your data as a data service instead of a portrayal service, then you have to use the web map service or web coverage service, rather the web feature service or web coverage service. The web feature service will allow you to deliver features. And by the way, these features are coming as a GML document. It comes as text data, and this software just basically translates it into polygons. And you can be able to do anything with it. You can be able to style it. You can be able to, do a lot of things with this kind of data. Yes. Okay, I'll check it. Let me first do this. So as you can see, you can be able to style it. So someone is asking, why does WebGIS provide WMS yet it is WFS and WCS that is preferred for the GIS analysis? Okay, the thing is that we have different specifications and they have different purposes. We said the first specification is web map service. The web map service only, if for example you're a data provider and you want to provide your data, you can only provide your data as a portrayal service. So you just portray to people, you just show them, advertise, just tell them this is my data, but if you want it, please come to me. So that could be the motivation behind it. So that when people are accessing it, they access basically a picture and it's geo-referenced, but then they can't do anything with it. They cannot use it furthermore for other analysis. That's what I'm just trying to say. But then you can also have your data given out to the public and you just say, I'm having this data in the server and whoever wants to access it can access it as a web feature service. That's basically for vector data. Or you can access it as a web coverage service for continuous surfaces. So I don't know whether I've answered you. So the motivations are different as to why you're putting these services. One of them is portray. For example, Google Maps or Google Earth, what they give you is their map. And their map, the best thing that you can do about it is overlay on top of it. But if you try to do image analysis on Google Maps, I don't think it is possible because they don't give you their data. They just portray it to you so that you can be able to see it. The best thing that you can say is maybe the location of this place, and that's the best thing that you can do on it. Or you do some routing on top of it. So that's basically some kind of algorithm to do the feature info. But you cannot be able to get that data and be able to analyze it. So their business model is, we provide you with data as a portrayal service so that you can see what we have and use it for only those business processes that would want you to use it for. But if we want to give you data as open data, for example, we just tell you that this data is freely available, you can pick it and use these specifications to be able to use it in your processing. So if, for example, I have a satellite image, I would provide it as a web coverage service so that you can get it and do analysis on top of it. You do image processing, for example. And if I have vector data and I want to provide it as real vector data that you can download, you can be able to use it for analysis, have it as input for analysis, and then I can be able to do that. Now, the interesting thing that maybe I should state is that if, for example, I had an algorithm here, if I had an algorithm in here, and maybe I want to do, let me see, for example, a clip or maybe a buffer. Let me try to do a clip. It is very possible for me to clip this layer. It's very possible to clip it. And I don't have to first copy it for me to clip it. I just put it there and clip it. And then once I'm done with my work, that service will just disappear. And so you invoke the service, use it, and then after you don't have to store on your PC. So I'm not sure whether I've answered you, Brian, but you can let us know. So is asking whether there is only WMS and not like the one where we could access it. Okay, once again, these are three, for example, there are so many services that we can have. Now, maybe I could answer this question from the perspective of the implementation. So the service is basically, we said web service is anything that utilizes itself on the internet and basically uses XML as a method of transport. This data that you're seeing that is coming to this software comes as though it is an XML document or a particular type of XML derived language, for example, GML. Now, what I'm saying is that we have different services. For example, we have the catalog service for the web that allows you to be able to store your data and be able to search it dynamically and be able to maybe evaluate it. Now, we have another service that you can have, which is WMS. In its own right, it is a service. And you can get the data in various formats. You can get the data, for example, in, if we checked add layer, so we add a web map service. If we try to, I'll try to edit before I edit it, just down here, you can see that you can get the data as these formats. In its own right, these are the formats that you can be able to get. But the purpose for this web map service, this type of service, is just to portray data only. It's not to give you data for downloading and then or putting in your algorithms and then being able to process it. The purpose is just portrayal. And I've given you an example. Google Maps provides you this data for portraying only. You cannot get that data and do, for example, image processing for remote sensing experts. You cannot do anything with it. But it looks very beautiful. They pre-styled it for you. So these guys have already styled their data set using the style layer descriptor. There's a way you do it in the Geo server. Now, I've also said the web feature service is also another type of web service. Now, for it, it allows you to get data as though they are feature data sets. You can get them as polygons, rather polygons, vectors, and points. Points, lines, and polygons. So if you want to represent discrete objects, so you can be able to get this data for discrete objects. And if you're dealing with continuous surfaces, then you get a raster that is processable when you use the web coverage service. So the motivation for using either of them depends on how basically you want to share your data or distribute your data. I don't know whether you've understood me, but that's basically, just get to know that these web services, each of them is a type of web service, not web map service. Web map service is a service, is a type. I know that in experts try to confuse these terms. Web service is the overarching term, and then web map service is one of those services that gives you a raster via HTTP protocols, and this is partially referenced, but you cannot be able to analyze it. And another type of web service is, is basically the web coverage service. It gives you a raster. You can be able to get all the values of that raster. You can be able to download it. You can be able to use it for your analysis. And the web feature service is also another type that basically gives you the ability to have points, lines, and polygons. If you're dealing, for example, with sensors, we would say you have the sensor observation service that basically tells you how to document all these measurements from the sensors. For example, if you have GPS points, rather GPS receivers, and you want to make sure that you give out this data from GPS receivers, there is also a specification that basically allows you to document that data, rather to serve that data in a particular way. Then we have, for example, the web processing service. Now, you don't need to buy software to be able to do your analysis. With the web processing service, what happens is that someone has algorithms, and then you can always go to this place and pick the rightful algorithm, apply it, and then be able to do your analysis. So I don't know whether I've been able to answer you, Brian, but please let me know. Okay, is there any other question? Please let me know. Okay, so these are the three services that we've been talking about. Now, there is a possibility that we can have also our algorithms. Not on this, you see this software here might have some algorithms, but it's very possible to develop third-party algorithms that you don't have to incorporate here. They're in a server. For example, Regional Center could develop us a tool for wetland vulnerability mapping and provides it as a web processing service. Now, what happens is that once you want to do your vulnerability mapping, you just go to their server and pick that algorithm, you invoke it basically, and then bind, and then be able to use it in other words, and that's it. So how is that possible? That is possible if you can be able to, for example, you come to the plugins here. So in other words, there is an experimental plugin here. I'll try to rather do it in ArcGIS after here. But there's an experimental plugin that you can be able to use. So you just have to go to manage and install plugins. Now, you have to make sure that you come to settings here first. For you are using Quantum Gis for the first time. And you have to make sure that you enable these experimental plugins. You have to make sure that you enable them. If you don't enable them, you're not going to see this plugin. And then you come to all here, and then you can type, for example, WPS, Web Processing Service. So you'll see something like WPS. So there are actually two kinds of plugins that allow you to do this. Tomorrow, I will introduce you to what we call the list map plugin, so that you can be able to see how these things are published. The web processing service is published using list map on Quantum Gis. Now, for today, at least we shall learn just the web processing client. So you basically have to click this and install it. For me, I've already installed it. I've already installed it. So this one, what it allows us to do, we can be able to access processes via HTTP protocols. And we have a particular standard that allows us to be able to access them. So these things are not going to change very soon. What I'm just trying to say, if you're a GIS expert, you want to access, for example, these processes. There's already a standard that tells you do A, B, C, D. The first one was to find out what the server does. And then later on, you can be able to click and say add, or maybe construct the whole link and put it in the browser and be able to show you the result in the browser. So we said it's platform independent, client rather development independent, development environment independent. And we've also said that for this one, you just basically have this plugin that allows you to be able to call this HTTP protocols. So once you have installed it, I hope you've installed it. That's what I've been talking a lot, so that you can install. Once you have installed it, then you close. So I'll try basically to make sure that I rather install it again or something like that. So once you install it, this thing must come here. So if you don't see it, you can just always go to the web and you'll see WPS client. But then you'll always see something here. You'll get this kind of dialogue. If you try to connect to the dialogue, now you can state now the link to your new server. For example, your server that is giving you this algorithm. For example, I can say AGRC, and then let me go back to my tutorial here. We've done all these things. In the tutorial, you'll realize that we have a link that I've given you. Okay, so I've given you a link to this server. And this server basically will allow you, so I just click here, connect, and then I go to that, and then I say, okay. So as you can see, I have this AGRC connection, and once I connect to it, it's going to fetch all the algorithms that this server gives. Now, some of these algorithms, so of course you can see there are so many. So in other words, what I'm trying to say, you don't need always to buy a sophisticated GIS software to do GIS. There are people who have already published these services, web processing service, and you can always go there and pick the algorithm and be able to use it. So these are the algorithms that are there. So for example, if I had this, and then I say, okay, once you're done, then you say, okay, let me run, and I see what happens. So it's running, as you can see. But this algorithm, I don't have it in this client software. I got it from somewhere else. It's running, and maybe it will give me a result. I'm running on data, which is basically a web feature service that I got from a web feature service, and I'm running it in a web processing service. So I'm chaining these different kinds of processes. And then it will give me a result to tell me whether I've been able to do it perfectly or not perfectly. So it will give me, for example, in this case, it has given me an exception report. So you have to parameterize it well for it to work. you have to read basically how it should be done. In other words, I went back to connect, and then you can see that I have all these many algorithms. In case you don't have that link, you can always use the default servers. Just click here and you'll find the default servers. But you can as well go and publish your own web processing service, and people consume these algorithms somewhere. Now, these algorithms can be consumed on the internet, but they can also, rather on the web client, that's basically the browser, or they can be consumed on, rather in this GIS, desktop GIS software. So in other words, it doesn't matter. Even on your phone, you can start running these algorithms. They should be able to run. So unless you have any question, then I could maybe proceed something else. So please let us know whether you have any question about these web services. Meanwhile, I can always go back to the presentation and then try to illustrate this. So once again, I say that what happens that someone has his data somewhere, and then he chooses how to share his data. So you could say, for example, I have my data, but I don't want people to use it for analysis. They have to come and pay me. Then he says, I think the best way is to use a web map service. Or he could decide to give this data distributed for free, or maybe distribute it using a key, but then he basically uses the web feature service or the web coverage service for raster data or coverages. And the users here, we've been here with our Quantum Gis, and we've been able to access these web services. I know that there are some people there who are ArcMap people. They don't want to use anything else. So for ArcMap, you basically have to go to the Arc catalog, and then you can be able to access these servers. So you basically have to come to your GIS servers, and you see also there is the ability for you to add services. So you can add, for example, your WMS or WCS. So for example, I can add my WMS. So I have to go to our link here. So where is our ArcMap here? And then I'm supposed to basically paste this here. And then I can say get layers, and we see. So you can see that there are so many layers that are there. You can even specify the version of your server, but this is optional. So you can see these are the versions that are there. So this is basically the capabilities of the server. You have to first know the capabilities of the server before you start getting the maps. And we said that what it gives you in this case is a raster. So if you say okay, then it's very possible to access all these layers, as you can see. Here you can just drag any of them to your, for example, the forest fires or the whatever. All these layers can be added here. Boundaries, poverty levels. Okay, it's not coming. So all these can be added here, as you can see. Now, I've already told you that these layers, you cannot be able to analyze them. If you try to download this thing here, you're just going to get a picture only. Now, there is a possibility that you can get also this, you can also create your, access your data also using the web map, rather web coverage service. So it will get you all the coverages here. So not sure why it's misbehaving here. I have to basically connect, and it's giving me first close. So somehow it reads them, but I don't know why it is. Because once you click here, you see that it's, no, it's not reading them actually. So basically, something that needs to be done. I don't know why it's not reading the WCS, but when you put here a link, it's supposed to read it also. Then for the WFS, I think you need to look for a tool. There's a tool that basically converts the WFS data. So you put the server here, and then you basically select the feature to extract. So you can see that it's allowing you to access, there's only one layer for the server. And then it's very possible for you to put what you want it to look like. Name, for example, I can call it maybe okay, I need to put it in this. Then I can call it anything. So I want it to be put into this database. So the output location is basically a database. Something is happening. I just want it to be in a database, basically. So as it is trying to think, my PC is trying to think, but as it's trying to do it, so after you basically run, something should be happening somewhere. So you can see something has happened. So it has succeeded and has saved wherever I saved it. So I just need to go and pick it. Okay. I don't know that I saved it here. No, I saved it in the default. So I just need to look for what I call boundaries. Malawi something. Okay, it's here. So it's here. It has been added. In other words, for it, you just have to basically use a tool. And this tool is from this search, WFS to feature class. So that's the way how actually you consume web map service, web feature service, web coverage service. The web map service is for getting just a raster, which is basically a picture. You can only overlay with it. You cannot do anything much with it. And it's just for portraying data. And the web feature service, you get points, lines, and polygons. Vector data, you cannot access the attribute table. And for the web coverage service, you get a raster data that you can be able to analyze and be able also to access the pixel values. So you can be able to process it actually. So that's basically it for how you could use ArcGIS to be able to access these services. Unless you have any question, please feel free to ask. WPS. Okay, someone is asking that he never saw the URL that I used for WPS, and I would like to basically bring back this URL. Moment. I'd like to connect. Maybe I'll edit. So literally today, one thing that I would want you to get away knowing is knowing that actually data can be served as web services. And these web services, the major advantage that it gives us is that you have this data effectively organized in one place. And then the issue here is that we should be able to consume this data, not store it. Not all of you should have a software with algorithms. Not all of you should have data stored in your databases. All this should be stored basically in one destination, and then we can be able to access it from wherever we are. So I believe that all of us, maybe 6 of us, have been able to access this data, and I mean, from one server, interestingly. You can imagine just a few minutes. And that's very beautiful. And then also, in that way, we reduce redundancy as far as data storage is concerned. And then the data is presented already using well-defined and standard presentation ways or structures. And of course, we have a transparent kind of provision in form of the data for the data. Now, we said that it works on any platform. It's based on the W3C, rather the Worldwide Consortium standards, as well as the OGC specifications. These web services are actually ISO standards. And maybe I want to show you this. When I showed you this yesterday, you're going to see that some of them are actually standards. So you'll notice that we have for example, we have 128 is the web map server interface. So that is basically one of those standards that we've been dealing with. So if you listed them, you'd find that actually we have also the other standards. But now the web feature service was bringing that as GML. GML is a standard here. GML is a standard 136. And then we said that we're using XML for the get capabilities. That standard is basically 1918, I think. The encoding specification. And then we said that WMS is a portrayal service. So we have a portrayal standard. So there are many standards that basically govern the way we deliver our data or distribute it. Now, I'm confident that at least you have an idea about web services now. So I'll try to repeat them from now another angle. From now the web angle, we shall also do that tomorrow so that we basically get the overall idea about these web services so that you know how to implement them also. It's very interesting for you to know how to implement them as a GIS expert. But today we've learned how to consume them. So tomorrow we want to learn how to implement them. So when you're writing, rather when you want to access the web map service once again, you're given the name of the server, and all you have to first do is to get the capabilities of the server. And once you have the capabilities, then you can be able to know what the server has. For example, know the layers that are there, the coordinate system, the format in which they can be given. So that's what basically the get capabilities document gives us. And we saw that it was just an XML document. Then you can also get a layer and describe it. Say, I want to know about this exposure layer, for example. And then it will tell you the characteristics of that layer. And then you can also have the get map. So in the client, basically we dealt with these two, rather the get capabilities and the get map. So you can also have the get feature info. You click and then it gives you the feature info. Now, when you're doing the get capabilities, I told you that the way you construct it is that after this question mark, you put there the service and you say WMS. So it's a key value pair. The service is the key, the value is WMS. And we said if you're dealing with WCS, the coverage service, you just put the WCS. If you're dealing with the feature service, you just put the WFS. And then the request is get capabilities. This word get capabilities should be written that way always. It's case sensitive. Now, once you do this, you'll get an XML document. You can also add the version. You can say version and then equals, and then you put that the version, for example, 1.1.0. But that is optional. So I've provided a table to show you what is compulsory if you're going to make a request to a server to know its capabilities. So the version is optional, the capabilities request is compulsory, is required, and the service name is required. Rather, the service is required, the service name is optional. If you wanted the map, then you have specify additional parameters. In this case, now the request type will be, the service of course will be WMS, as you can see. But then the request in this case will be get map. That's the operation that we use. So remember here we said that we had the various operations. So in this case, the request will be get map, not get capabilities, but get map. Now you want the map. And now take note that you can specify the version, it is optional, but when you want to separate these key value pairs, use the ampersand sign as we said. But in this case, for the get map, you have specify the layers. So you say request get map, then specify the layers, then you specify the layer itself. So the layer is called Malawi vulnerability, national exposure. And then of course there's a space, that's why there's that percentage sign. And then there is a bounding box. The bounding box is basically, you have to specify the extent of the layer that you want to pick, because this layer could be filling the whole country, but you say, I just need only for one district. So you specify the corners so that it picks only that bounding box that you want. So these are basically coordinates of the bounding box. So you have the X min and the Y min, then X max and Y max. So that's what basically is here. And then we have the width. You have to specify the width of that picture it's going to bring. So you put basically its width and its height. And you have to specify the coordinate reference system. So in this case, you see the spatial reference system, SRS, is denoted by EPSG 4326. Okay. So please, Brian, please.
Can you hear me? Hello? Hello?
Yes, we can hear you.
Okay, yeah, thank you, Alan, for the interesting lecture. Now, I wanted to ask on this WPS client, just for you to help clarify something. We in error because I had gone off a bit because of internet. I used the link for RSMRD and it work. Then when I got this new link you gave, it worked. Now for it brings, for example, you have create Verona diagram. It's not like layers. It's not like data layers. It looks like it's an intermediate. You have like create points along. It's like a process. So I wanted you to clarify the bit of difference with this WPS when you connect to the servers. I don't know if the question is clear.
Yeah. So with the WPS, what happens is that these are processes that are like GIS algorithms, like the way you have algorithms in the R catalog, or you have those in QGIS in the processing toolbox. So these algorithms are held on servers. So these algorithms, some of them are third-party algorithms. They are, for example, you could do, for example, a tool that maybe does terrain processing, and maybe it's particular to your organization. So if you want basically your clients, or maybe people to be able to access it and be able to utilize it, then they can be able to invoke that service and then be able to get it as a process, an algorithm, and then do the analysis. Now, the interesting thing is that with a web processing service, then you can be able to complement on the tools that you have in the client, rather in your client software. And in case you don't have a client software, you don't have to say that I can't do GIS. You just go to some guys who are hosting these processes, and then you can be able to pull them. So a process could be, for example, a simple one calculating maybe the perimeter of a wetland, or maybe it can even be a complicated process like hydrological modeling process. And then you have algorithms that are already chained together, and then you can be able to add your data and then add it, parameterize these algorithms or these processes. And then you click OK, and then it gives you a result. And then when you're done with your processing, keep it on your computer. So because it's hosted somewhere. So you invoke it, execute, and then that's it. So yes, I think, Brian, I've answered your.
Yes.
I can see you told me
clear.
that you get the difference. I don't know whether.
Yes, I get it.
You've gotten
I
it,
understand.
but if you have, please let us know also. Okay, so thank you very much. So what we do is, I'm still going back to this, since we are remaining with only 3 minutes, maybe I'll ask you for 7 minutes so that I can finish at this web map service. Tomorrow we can have our recap and do the web coverage service and the web feature service and the web processing service from the slide perspective, as well as from the web perspective, the browser, using the browser. So with the get map, like I told you, these are basically key value pairs. So I'd reached here where you have specified the spatial reference system, which is EPSG 4326. And then you have specified the format. It could be like open layers, or it could be GeoTIFF, whichever. And if, for example, you clicked one of these, sorry, shit. clicked one of these links, then you should be able, it should be able to take you to a map. Okay, I have to go to the map here, right to the URL, rather the browser. Now, if this link is not right, then we're going to have problems. It has to be right for it to bring you a map. So you can see the map. And if I click anywhere here, you should realize that I get the get info, but I don't get the pixel values. That's for the web map service once again. Remember, we could run it, consume it. We could consume it in the ArcGIS or Quantum Gis, but we can also consume it on the browser. That's what I'm trying to say. And interestingly, if you are a software developer, you could also consume it in the software code. So it depends on how you want to consume it. So it's independent of the development environment once again. So these are some of the parameters. You look through them maybe over the night and just appreciate them. And I've put there a table to show you which of them are very compulsory, which of them are not compulsory. R means required, and O means optional. So you can be able to check them overnight, and then tomorrow we can talk. So the get feature info is what I was just showing. When I clicked, I got information about that place. But I never got the pixel values. I just got information about that place. So also you can be able to create a link. And I've just told you that these key value pairs are only separated using the ampersand sign. You can put all of them and separate them using the ampersand sign. So this is the key and this is the value. You have the value here. You have the key, which is like the version, and then the version number would be the value, or the SRS, and then the value would be EPSG something. Then we can also describe the layer. Here is basically an example of what a described layer looks like. And this, we've already done it in our activity. So if you follow that tutorial, you should be able to access all the data sets. So we are very lucky to deal with web feature service, which looks similar to the web map service. And we shall also look at the different types, the transactional as well as the basic one. And then also we shall look at the web coverage service again as a standard, and see how basically we can be able to run it. And then we shall also look at the web processing service. So either way, if you've not gotten it today, tomorrow you'll be able to get it. So there's no way you'll escape getting to know it. So thank you very much. I would like to stop here and maybe receive any questions and concerns. Please help us and tell us so that we can be able to change for the better. So that question, I think for the training, when to start, Professor Anthony will communicate, but at least I knew that it should start at 2 tomorrow. That's my understanding. But in case there is any change, it can always be communicated. Thank you, Brian. Brian says that he has learned something, and so that's very interesting to hear. So Professor Anthony says that the class will be in the morning. So let us log in the morning. I'll be there also at 9 o'clock. I'm also going to write an email to let you know that the class is there at 9. So either way, we shall be able to get that email. The training is tomorrow in the morning. So because we have a public dialogue tomorrow in the afternoon. So let's come again tomorrow at 9 a.m. Meet. Someone is asking, is it possible to access Google Earth Engine data using these web services? Well, I've not yet explored so much about Google Earth Engine as well as the web services, but my understanding of Google data, rather Google Engine, is that they provide you with an API, programming interface, for you to be able to consume. What it found out is whether you can be able to consume data from other web services onto Google Earth Engine in their API. So that I've not been able to find out. But maybe overnight I can try to find out and let you know, Enoch, tomorrow in the presentation. So Enoch says that actually you can use the Google Earth Engine API to be able to consume data outside of the Google Earth Engine repositories. So thank you very much. I'm still waiting for the questions. I'll be around and we can always leave at leisure.